Hello there. In this video, we'll break down what the command and control servers are, core features, core components, and popular C2 servers with an example of a basic infrastructure to protect the attack server. Grab a coffee and let's do this. Imagine the center of a warfare operation. The command and control server work as this, and the names are from a military context. Command refers to orders and control to the management. C2 servers centralize the target management as a control panel. It can be through a graphic user interface client or a command line application, but in order to understand how it works, let's dive into core features and components. There are two main concepts. The name of these components change between C2 versions. Agent, also called beacon, implant, or daemon, it is the software component delivered to the target. It does a callback connection to the server to retrieve tasks to execute like running a system command, exfiltrating information, or downloading payloads. Listener, it is the server component that waits for the agent connection. Listeners are configured to catch communication in specific ports and protocols, for example, HTTP or DNS. C2 server operator. It's who controls the server, generate agents, configure listener, and manage the infected devices. Some versions of command and control servers can have their own custom components. Well, but how the communication works? In a very basic workflow, agents don't keep alive the connection with the C2. It sends requests in a preconfigured time period, sometimes with a variation called jitter. For example, an agent configured to send a request every 30 seconds with a jitter of 10 seconds will send a request every 30 seconds plus or minus 10 seconds of the jitter are just 30 seconds each change randomly to try break the time pattern. C2 send a task to the agent like a signal or publication, and then the agent sends a request to check for the pending task and retrieve it. Here, C2 doesn't communicate with the agent directly. The agent does checks for these signals. This is the reason to call beacons to the agents. The check can be an HTTP GET request to obtain information from an endpoint. In this case, the command and control server. The agent receives the task and the request response. It increases tilt because HTTP is not where communication protocol. With a task in the target, device agent execute it and send the result back to the C2, and repeat the process every time when the period to send the new request is over. In HTTP communications, the logs can show an unsuspicious request, like a post petition to register a user account, or a get to retrieve an image, or other common endpoint syntax. In some cases, the operators are more components with infrastructure protecting the C2 server, for example, that dropper resolvers or endpoints to get the task without direct communication to the server, for example, a Discord server. Here, the agent sends the request and receives the task in the Discord server. If Discord is a common service in the target network, it can be camouflaged with the normal network traffic. Also, dead dropper resolvers can be used to get the endpoints to communicate with the server, allowing a dynamic endpoint change. Another common platform to use as dead dropper resolver is Telegraph, which is similar to Medium but anonymous. This concept is based on spies that exchange information with hidden location without a direct interaction. Another key component to improve the command and control server OPSEC is a redirector. This is a server, in some cases a web server, running a fake website as a facade. It is the endpoint which the agent sends and retrieves the data, and this server sends the web traffic to the C2 server. It's common to configure the redirector with specific parameters to know when redirect the traffic. For example, a specific user agent, a root, or a URL parameter. Setting up a redirection in a server is very simple and allows you to hide the real C2 infrastructure. And what about the command? One of the main features of this server. Well, as I mentioned above, there can be system commands to execute, for example, the basic like pwd, who am I, cd, cp, mv, or init and ssh connection. check for running service in the target host and list users, or other offensive jobs like downloading a new malware payload to improve the attack chain by deploying ransomware in the same target or in other device in the same network. This is a critical action because devices in the same network have a good trust level with their networks, and in ransomware attacks, it's common to spread the malware among the target network. If the target is a user computer and not a server, some command and control servers can send specific tasks to take screenshots or run other post-exploitation features like capturing credentials from a web browser or init a keylogger. Let's talk about one popular command and control server, Sliver C2, developed by Bishop Fox. But before, if you want to know more about the architecture and technique specification of Sliver in depth, please check out this Medium article about it in this link. It is a good technical review from my friend Lars Murak. Sliver is a command line command and control server. That means it doesn't have a graphic interface. Operators connect to it with a terminal. It is very simple to install and operate, and also have some evasion features to implement in offensive operation and provides detection notification called canaries that do an advertise if a SOC analyst discovered the agent, or in this case call it implant. It can be used in addition with a redirector like the previously mentioned, and support different communication protocols for implants like HTTP, HTTPS, DNS, TCP, MTLS, and WireGuard. And have these different protocols help us to choose one depending on the target context. The generated payloads with Sliver can be in different formats like XS, DLLs, or shellcode. It allows to improve the evasion and customize the payload, or for example in shellcode cases add it to or custom dropper. But if you want some graphic interface C2 server, here is Mythic. Accessible from web browser, it also provides different payload formats with the option to customize, and this is in my favorite list. The capability of being used from a web server makes it possible to set the access from a fake web application endpoint or with other protocols like Tor. Also, their agents can be used with redirectors and have the capability to use different network protocols to communicate with the C2, as well as the option to generate payloads for different operating systems and architectures. These two examples are open source projects. This is very important because we can read their code and understand in depth how they work. If we want to develop our own, we can base it on the existing projects and their internals. As you can see in this video, it was an introductory one, because C2 servers need individual reviews for the different structures and features that they have. They can be used for malicious actors, but they are not only used for the bad guys. We as red team operators can also use them to perform our security assessments or an offensive operation against the baddies. If you like these topics about offensive tools, keep in contact, and in the next video I will show you how to set up an infrastructure of a command and control server with redirectors and targets, and not only in a local laboratory, to make it similar to the real-life attackers' TTPs. Thanks for watching, I'm Osai. If you want to keep up, follow me on socials. Know the threat and stay safe.
If you're passionate about malware and cybersecurity, I've got something awesome for you. Check out our academy focused on ethical malware projects. We offer a range of courses to boost your skills. First up, there's Introduction to Windows Malware Development for those getting started. Next, dive deep with Building a Custom RAT to create your own remote access tools. And for those wanting to analyze and understand malware, there's Introduction to Malware Analysis. But that's not all. We also have our Malware Development Modules, mini courses that cover specific topics like evasion techniques. Join us and level up your skills